Hey guys, this is 5.4. We are going to look at dividing polynomials. This is going to be extremely important as we go into 5.5 tomorrow because that whole section involves being able to divide polynomials. So make sure you get this skill down before you move to 5.5. So before we get into division of polynomials, let's do an elementary example to review dividing just integers. So you learned in elementary to divide these probably using long division, like so. And so the first thing you would do is say, how many times does 3 go into 2? And obviously that's 0. So then we move to 25. How many times does 3 go into 25? So we would say 8, and we would multiply 8 times 3 is 24. And we would subtract 25 minus 24 is 1. And then we would bring down the 6 and start all over. So you would say, how many times does 3 go into 16? And you'd say 5. And 5 times 3 is 15. We subtract, and we have 1 left over. And you would call that your remainder. Maybe you wrote remainder 1. So 85, remainder 1 is your quotient. Okay, so let's label these to kind of review some terminology when it comes to division. So this first number, that is your dividend. So if you see that word dividend, it's the number you're dividing into. That's how I remember it. Dividend, I'm dividing into that number. And then your divisor, that's what you're dividing by. And then your answer, this is your quotient. And of course, that 1 right there is your remainder. All right, so that's something that just a little review, but we are going to look at how to do long division of polynomials, and then we'll look at a little bit of a simplified version of dividing polynomials that only works with linear divisors. All right, division algorithm. Let f of x and g of x be polynomials with g of x of lesser degree than f of x. So what that's saying is you can only divide by a polynomial that has a degree lower than your dividend, right? So I'm not, like for example up here, I'm not going to divide by a number that's bigger than 256. Okay, so same thing with polynomials. The degree of the divisor needs to be greater than the degree of the dividend. Oh, sorry, I said that backwards. The degree of the dividend, the one inside, needs to be greater than the degree of the divisor. Okay. And g of x of degree 1 or more. There must exist unique polynomials q of x and r of x. So they named these q of x meaning your quotient, and r of x your remainder. So q quotient, r remainder, such that f of x equals your quotient, q of x, times what you were dividing by, g of x, plus your remainder. There exists unique polynomials q of x and r of x such that you can write it that way. Now what does that mean? Let's look back at our elementary example to kind of simplify this. So all that's saying is your dividend, which was f of x here with the polynomials, so up here your dividend was 256 equals the quotient, so that's 85, times g of x, which was your divisor, so times 3, plus your remainder. Okay, and you could check that and make sure that it works, but 85 times 3 plus 1 gives you that number that we were dividing in the first place. Okay, so all it's saying is you can split it up into those factors and then add on the remainder, and that should work every time. All right, so let's look at a polynomial example of this. We don't know how to actually divide these yet, but let's just label these with the vocabulary that we've been talking about. So first of all, this guy is your dividend. That is what you're dividing into. This one, that's your divisor. Notice that it has a degree less than the dividend. That has to be true. Okay, and then we have our quotient. And the 4 up here, that is your remainder. Notice that the remainder goes over the divisor when you're adding it on to the quotient, right? Because I'm trying to divide this number by x minus 1, but I couldn't, and that's why it's left over. So when I add it on to my quotient, I add it on, still being divided by x minus 1. Now if I want to write it this way, I would have my dividend x squared plus 5x minus 2 equals my quotient times my divisor plus just my remainder plus 4. And you could see that if you FOILed these together and then added 4, it would come out to x squared plus 5x minus 2. Okay, so we just broke it apart using division. All right, long division. So we're going to perform long division exactly like you did up here in our elementary example, but with polynomials. You should have seen this in Algebra 2, but we're definitely going to review it here. All right, so first of all, your dividend going inside the house, as you probably called it in elementary. Okay, and then dividing by 3n plus 2. Okay, and here's how this works. So I like to teach it this way in Algebra 2, since I also teach that, but you're going to follow these steps. Divide, multiply, subtract, and bring down. The same steps that you followed up here. So we did 3 divides into 25 8 times, or 25 divided by 3 is 8. And then we multiplied 8 times 3 is 24, and then we subtracted, and then we brought the next number down. So same process here. First we're going to divide. When you divide, you just want to look at the first 2 terms in your dividend and your divisor. So 12n cubed divided by 3n. If you need to write this out to the side, you can. All I care about is what that comes out to. So 12 divided by 3 is 4. N cubed divided by n is n squared. And so that's what we get on our first division. Now we multiply. 4n squared times, now this is important, 4n squared times this whole thing. So you need to distribute it to both of those terms there when you multiply. Okay, so 4n squared times 3n is 12n cubed. If those two don't match, you messed up. The whole point of dividing those two is so that when you multiply, you get the exact same thing right here. Hence, when we subtract, we're going to have 0. So if you didn't get that, you're off to a rough start. Okay, now we distribute that also to the 2, so that's 8n squared. Okay, so that was the multiply step. Now we move to subtract. You want to subtract both terms. So 12 minus 12 gives me 0. Those cancel. That should happen every time. And then I have 11 minus 8. That's 3n squared. And then we move to the next step, which is bring down. And we start over. So divide. 3n, still looking at your first term, going into your first term. 3n goes into 3n squared. So you could say 3n squared divided by 3n gives me just n. Gives me just n, so I put plus n. Then I multiply. N times 3n is 3n squared. Perfect, they match. N times 2 is 2n. So remember, you're distributing this n to this whole 3n plus 2, and that's what you're writing underneath here. Now subtract. These two cancel. 5n minus 2n. 5n minus 2n is 3n. And then we're ready to bring down. And we do it one last time. So now, divide, multiply, subtract, bring down. 3n divided by 3n. That just equals 1. Okay, so plus 1. We multiply 3n plus 2. We subtract, cancel, negative 8 minus 2, negative 10. And that is your remainder. So that very last number, that is your remainder. And you always want to write that over your divisor. So minus 10 over 3n plus 2, right? Because we're trying to divide the negative 10 by 3n plus 2, but we can't. So we're just going to tack it on to the end of our answer to say that we still have that additional part left over. Negative 10 divided by 3n plus 2 was left. Okay, so let's just write that final answer down here. We got 4n squared plus n plus 1 minus 10 divided by 3n plus 2. That is your quotient. All right, let's try one more. Going through that process. If you're feeling comfortable, feel free to try it on your own and then check your answer. If you need to see it walked through, just listen up. Actually, you need to listen up for the setup anyways, because we're missing a term here. So notice that this goes from x squared to just your constant term. When that happens, at any time during division, you need to make sure you insert a 0 for that missing term. So this is, I'm just going to rewrite this, x squared plus 0x plus 2. So we were missing the x term, so you're just going to insert that 0x. Now look at your dividend. It goes from x to the 4th to x squared. So we're missing the x cubed term. So we need to insert a 0x cubed into this part as well. So just remember, when you're doing division of any kind, long division or synthetic, what we're about to learn, you need to insert a 0 as a placeholder for any terms that are missing. All right, so let's write this out. We are doing x squared plus 0x plus 2 into 8x to the 4th, 0x cubed, 12x squared, 7x minus 18. All right, I know this one looks longer, probably scarier, but it actually makes it easier having 3 terms here. It makes the problem end faster because we're dividing by a trinomial instead of a binomial, okay? So let's take this one step at a time. Divide. 8x to the 4th divided by x squared is just 8x squared. So then we multiply. That gives me 8x to the 4th. Make sure we distribute this to all 3 terms. Okay. So that's plus 0x cubed plus 16x squared. Then we want to subtract. Cancels. 0 minus 0 also goes away. I've got 12 minus 16, negative 4x squared. And I'm ready to bring down. Okay, and we start over. So, forgot to write my steps over here. Subtract, and then we brought down. Start over. So divide negative 4x squared divided by x squared. And that gives you negative 4. And then we multiply negative 4 times all 3 terms here. Okay, forgot that we actually need to bring down another term here. So that happened because 2 terms canceled in this one step. So we got to bring down 2 terms instead of 1. Okay, and then we subtract. Okay, so negative 4 minus negative 4 is 0. 7 minus 0 is 7. Negative 18 minus negative 8, that becomes negative 18 plus 8, which is negative 10. Okay, so that whole thing is your remainder. There's nothing left to bring down. So this is the remainder. Okay, so we're going to do plus 7x minus 10 divided by our whole divisor, x squared. I don't need to write that 0 term there, so x squared plus 2. Okay, and I could just box my answer here. All right, so that is long division. Divide, multiply, subtract, and bring down. If you're ever having trouble, just refer back to an elementary example to remember what you should do next. Now let's look at synthetic division. Synthetic division is a shortcut that can be used only when the divisor is a binomial in the form x minus k. So it has to be linear, like there's no squared term here. And it's a binomial. There's only 2 terms. So you're only going to have x minus some number, k, where k is a real number. In synthetic division, only the coefficients are used. So you actually just leave out any variables, which makes it move a lot more smoothly. and quickly, so that's why it's considered a shortcut. So this is going to be a lot easier, and you're going to say, Ms. Kaiser, why don't we just do this for all of the problems? Why did you even show us long division? The reason is obviously because this is limited to only binomials. It could not do what we did up here where we divided actually by a trinomial. It could also not do where you're dividing by a quadratic. So it's just very limited. But if all you're worried about is dividing by linear binomials, then synthetic division is your best friend. Okay, and honestly, in 5.5, synthetic division is all you're going to need, but you still need to know how to do long division as well for the course, for the final exam, for all of those reasons. All right, so how does this process work? Okay, so the first thing you're going to do is you're going to take your divisor and you're going to actually take this number, change the sign. So because notice this is x minus k, and k is the number you actually want to use. So we're going to use the number 3. So take that number, the k, you want to change the sign. And you're going to put it in a box like so. And then you want to take your coefficients, make sure there's no terms missing, 3, 2, 1, and then this would be x to the 0. So make sure no terms are missing, and then you want to list out your coefficients. So we're going to have 4, negative 15, 11, negative 10. Okay, so those are all going over here. These are your coefficients. Okay, and then we're going to draw a little line a little bit below those coefficients. All right, so that's the setup. You're taking this number, changing the sign, so give you 3, listing out your coefficients, making sure there's no terms missing. Okay. Now, the first thing you do in the process is drop this 4. Bring down that 4, the first number, bring it down. Okay, and then you're going to multiply the number in the box, that k, by the number in the bottom row, so 3 times 4. You're going to write it underneath the next number, so that gives you 12. So you're just multiply 3 times 4, write it underneath the next number. Then you want to add. We are adding down for all of these. So negative 15 plus 12 gives me negative 3. Then start over. Multiply 3 times negative 3, negative 9. So we multiplied and we brought it up here. Then we add 11 plus negative 9 is 2. We start over. 3 times 2 is 6. Add negative 4. Okay, so it's bring the number down, multiply, add, multiply, add, multiply, add. Okay, once you get to that last number, this last number here is always going to be the remainder. That is your remainder. And so now, what do these new numbers mean? What does the 4, negative 3, and 2 actually mean? These are actually your new coefficients. So you're going to have 4x squared minus 3x plus 2, and then you have your remainder, which I can write plus negative 4 or just minus 4. It doesn't really matter. So minus 4 divided by, again, always dividing by your divisor, x minus 3. And so that's your answer. Now, one thing you may be wondering is, how did I know which degree to start with here? It is always going to decrease, your degree is going to decrease by 1 from what you started with here. So my dividend started with degree 3, so this is going to be degree 2. It always decreases by 1. So degree decreases by 1. Okay, always goes 1 down, and then you just don't skip any terms as you write out, as you use your coefficients to write out your new terms. All right, so that's that. Let's try another one. So first, taking this number, changing the sign, box. List out your coefficients. Okay, so I have 4, 3, 2, where's my x to the 1? So I need to insert plus 0x to the 1, okay? So I need to put a 0 here. That term was missing, so I added a 0x in between my x squared and my constant term. Okay, so we drop down the negative 11. We multiply negative 1 times negative 11, add, multiply, add, multiply, add, multiply, add. Okay, this last number, I like to circle it. It's my remainder. And now we can write our new answer. Okay, so going down by 1 degree. Okay, so my new degree is going to be 3. So negative 11 cubed plus 13. Oops, sorry. I didn't even write the x. Negative 11x cubed plus 13x squared minus 21x plus 21. And then your remainder, minus 25 divided by your divisor, which was x plus 1. Perfect. Let's do one more. And remember, you are going to need to be able to do this in 5.5, so make sure you get really proficient at it. The more you do this, I mean, it's just super simple once you do it multiple times. So change the sign. So we have negative 1 again. Now, lots of terms missing here between x to the 5th and x to the 0. So that is actually going to be x to the 5th plus 0, x to the 4th, plus 0, x cubed, plus 0, x squared, plus 0, x plus 1. Okay, so make sure you insert 1, 2, 3, 4 zeros there. So 1, and then we have 4 zeros, and then we have a 1. Okay, so try this if you're feeling comfortable. Try it on your own. If not, I'm going to do this one with you. So bring down the 1. Negative 1 times 1 is negative 1. Add, multiply. So you're doing negative 1 times negative 1 down here. Positive 1, add, multiply. Negative 1 times positive 1. Add, multiply. Add, multiply, add. So notice this one actually has a remainder 0, which is going to be significant as we look at 5.5, but remainder 0 on this one. So our new coefficients, going down by 1 degree, so instead of starting with x to the 5th, we're going to start with x to the 4th. So I'll have 1 x to the 4th minus x cubed plus, since it's a positive 1, x squared minus x plus 1. No remainder, so I don't need to write anything with that 0. And that's it. That's synthetic division.